Hello and welcome to lesson 4.8, Isosceles and Equilateral Triangles. Today's objectives will be to prove theorems about isosceles and equilateral triangles and apply properties of isosceles and equilateral triangles. Here's a list of your vocabulary terms. Once again, make sure you are going through using your textbook to fill in vocabulary both in the note packet and in your vocab notebook before you begin watching the video. So recall that an isosceles triangle has at least two congruent sides. The congruent sides are called the legs. The vertex angle is the angle formed by those legs. The side opposite the vertex angle is called the base, and the base angles are the two angles that have the base as a side. So in this diagram, angles 1 and 2 are called the base angles. Angle 3 is the vertex angle. The side formed by angles 1 and 2 is called the base. The sides formed by 2 and 3 and 1 and 3, or the sides that form angle 3, are called the legs. We'll start off with these two theorems. The first is the isosceles triangle theorem. It states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Basically, this is stated up much more simply by saying the base angles of an isosceles triangle are congruent. The converse of that is also true, that if you have a triangle where the base angles are congruent, then the opposite sides of those angles are congruent. So if in a triangle we have two angles that are congruent, then we can say it's an isosceles triangle with congruent legs. The isosceles triangle theorem is sometimes stated as base angles of an isosceles triangle are congruent, like I said a minute ago. So let's take a look at example 1. In this example, we have what looks like a house drawn. We have a four-sided polygon, or a quadrilateral, with a triangle placed over the top of it like a roof. And we're going to explain why the length of yz is the same as the length of yx. We're given that it's 20 feet. Well, in this diagram, you'll see angle x measures 40 degrees, and the exterior angle at z is 140. That means the interior angle, which forms a linear pair, would also have to be 40 degrees. So it's 40 degrees, which is the same as angle x. Since those are congruent angles, xyz is an isosceles triangle by the converse of the isosceles triangle theorem, which means that yz is equal to yx, or 20 feet. Let's go ahead and take a look at example 2a. In this example, we are asked to find the measure of angle h. Well, remember that in a triangle, all three angles must add up to 180 degrees. The vertex angle of this isosceles triangle is given to you as 48 degrees. So we also know it's isosceles, so g and h must have the same measure. We're going to call that x, because I don't know what it is, so we're going to replace it with x at the moment. So the measure of all three must add up to 180, so x plus 48 must equal 180. We can solve this equation for x fairly simply. You get 2x equals 132 when you subtract 48 from both sides and combine like terms. Dividing by 2, x is 66. That means the measure of angle h is 66 degrees. All right, let's take a look at example 2b. We're given another isosceles triangle with base angles n and p, and n is expressed as 6y degrees, p is expressed as 8y minus 16. Remember that in an isosceles triangle, base angles are congruent. So their measures must be equal, so I can say that 6y and 8y minus 16 are equal. We can solve this equation for y, plugging it back in to find the measure of angle n. Why don't you take a few moments, pause the video, and solve this equation for y. Okay, you should have gotten that 2y equals 16, so y equals 8. If we take that value and plug it in as 6 times 8, we get the measure of angle n is 48 degrees. Why don't you take a moment to try and work through example 2c. This one's going to be a lot more like example 2a, but take a few moments to try and solve for the measure of angle F. Again, pause the video if you need more time, but we should get something kind of like this. You know that F and D must both equal x, so if I add all three angles, I must get 180. X plus 22 equals 180. If I combine those two x's and I subtract 22 from both sides, I get this. Many of you may have started with this equation, knowing that each of these added together must equal 158 because you did the 22 subtracted from 180 first. That's okay, as long as you get that x is 79. Now, that is the measure of angle F and D, so the measure of angle F is 79 degrees. Now for part D of example 2, we need to find the measure of angle G. Once again, I'll allow you to work through this one. Pause the video if you need any more time. Alright, you should have gotten something that looks a little bit like this. These two base angles are congruent, so their measures are equal by the isosceles triangle theorem. So x plus 44 equals 3x. Solving this equation for x, we get 22 for that value. When we take 22 and add it to 44, you get 66 degrees for the measure of angle G. Alright, in this lesson we have another corollary, two more actually, that will come from our understanding of equilateral triangles. Corollary 483. If a triangle is equilateral, then it is also equiangular. That's something we've mentioned several times throughout class, but it does come from our understanding of what an equilateral triangle is. If you were ever to use this in a proof, you would need to write this statement: equilateral triangle leads to equiangular triangle. Or if we have an equilateral triangle, then we have an equiangular triangle. Since ABC is given as equilateral, we can conclude that all three angles are congruent. And corollary 484 is just the converse of that. If a triangle is equiangular, then it is also equilateral. So let's take a look at example 3a. We are given an equilateral triangle and asked about the angle measures. So we're using that first corollary. If it's equilateral, then it's also equiangular. So I know that 2x plus 32 must be the angle measure. We know that the angle measure of all equiangular triangles is 60 degrees. So 2x plus 32 must equal 60 degrees. Solving the equation for x, we find that x equals 14. Again, you don't need the angle measure. We know that. We know all angles of an equiangular triangle are 60 degrees. So our answer is x equals 14. Why don't you work through this problem to find the value of y? We are starting with an equiangular triangle. We have a corollary from this lesson that says if our triangle is equiangular, then it's also equilateral. That means all the sides are congruent. That means these two values must be equal. So start off by setting your equation 5y minus 6 equals 4y plus 12. Solve the equation for y. Okay, if you need any more time, pause the video, but if you're ready to move on, we should have an answer that looks something like this. When you subtract 4y from both sides and we add 6 to both sides, we get that y equals 18. And that will conclude our notes for lesson 4.8. This has been a little bit shorter lesson, but that'll give us time to answer some quick questions in class Friday. Remember, you will have a quiz over lessons 4.1, 4.2, and 4.8 at the end of class on Friday. Hopefully this has been helpful. If you want to go ahead and take a look at the homework over lesson 4.8, I have attached that to the Edmodo post. Please feel free to look at that before you come to class. Otherwise, we will work on this assignment during class.